Hello, in your previous videos and reading, you've looked at bulk packing for metals and for ionic complexes. Today, we're just going to look at a couple of examples for determining empirical formula from an ionic lattice. So we'll start with this example, and it's a generic one. So we've got these darker, bigger atoms we're calling A. And the packing type for that, we've got one on all the corners and one on each face. So this is a face-centered cubic. And when we look at face-centered cubic, we have 1/8 on each of the 8 corners, and 1/8 of those atoms are within the unit cell. Plus we have 6 on each of the faces, and half of those are in the unit cell. So we get 4 total atoms of type A in the unit cell. Then we have these smaller white ones, blue if I color them in, and these are in our tetrahedral holes. And they're in 4 of the tetrahedral holes. And remember that the tetrahedral hole is completely inside the unit cell. So we have 4 of these atoms in our tetrahedral hole. And we have 4 in the face-centered cubic. So the empirical formula for this salt is just AB. You could say AB for A4, B4, but we always show the lowest ratio, which is A1, B1. So here's a similar one where you actually have to fill in some of the drawing. So the chloride ions are not drawn in yet. The barium atoms are already in the face-centered cubic again. So barium is face-centered cubic, which we've just calculated means there's 4 total atoms in this unit cell. Then it asks you to put in the chlorines into all of the tetrahedral holes. So there are 8 tetrahedral holes. So if we draw all of those in, that goes like that, and then there would be 8 chlorines. So my ratio would be barium 4, chlorine 8, and so we do the lowest ratio, and that will be barium 1, chlorine 2, and one of the questions you are asked is, does this agree with your chemical tuition? Well, we have a +2 here and a -1, so we would expect that there would be 2 chlorines for every barium to get a neutral ionic packing cell, and the unit cell must be neutral. The other question here is, what is the coordination number for the barium? And this one is a little trickier because you have to realize that this, for the unit cell, this continues on in all directions. And so if you imagine these continuing, there's my bad drawing, that is really in another octahedral. This is in an octahedral or cubic hole. So this has a coordination number of 8 because there are 8 atoms surrounding this barium.